welcome to the token efficiency panel. I have joining me on stage today, Zain Asgar, co-founder of Gimlet Labs, Srikanth, Anaparetti, EVP at Netrodyne, Naveen Rao, CEO of a new exciting company, and Jay Ram, the founder and CEO of HUD. So before we get started, why don't you guys all tell us a little bit about what you're working on with your companies, and we'll have a couple of questions to talk about token efficiency for all of you.
Starting with me. Hey, I'm Zain Asgar, co-founder, CEO of Gimlet, and also faculty member at Stanford, working on efficient AI. Similarly, Gimlet Labs also works on efficient AI. And what we specifically work on is making it easy to partition and map workloads across heterogeneous hardware.
Hi, so I'm Srikanth, and I work at Netrodyne. Essentially, I work on edge AI, and we deploy essentially like perception and reasoning models to essentially like one of the largest AI-powered dashcams in the world. And my work is pretty much like the thesis of this panel, which is about how do you develop like efficient AI that can be run on very cheap hardware at scale.
Hi everyone, Naveen Rao. I apologize, I lost my voice yesterday, so just from being sick. I passed it now, don't worry. Yes, I'm the CEO and co-founder of a company called Unconventional AI, and basically, Michael, you did my entire pitch, and we're thinking about it in a radically different way. We've been building the same digital machine for 80 years. Literally, 1940s is when we went to digital, and there were a lot of good reasons for it then, and it took us to where we are today. But we're not fundamentally extracting everything we can out of the physical universe in terms of computation. So in essence, a parameter of a transformer is not a hardened scientific concept. It's something that is very specific to the way we build AI today that's been built on digital machines. So we're actually kind of rethinking the entire stack, how I express a neural network, how I actually build new kind of hardware that exploits the physics in novel ways.
Awesome, yeah. I'm Jay, CEO, founder of HUD. We're a platform for building reinforcement learning environments for LLMs. So we work with foundation labs, startups who want to build RL environments, and now also enterprises who want to build RL environments. And we provide the infra and also sometimes the data.
Okay, well, I think we can get back to this question of token efficiency. One thing that perplexes me a little bit is we are adding all this capacity. Every month there's another expansion of new data centers, new partners to the hyperscale or neocloud world, and yet we appear to have just no GPUs to spare. That is an opportunity and also a problem. For each one of you, what's the biggest strategy you could see to try to unlock either, again, the opportunity for you or overcome the challenge for scaling your business?
Sorry,
Let's
sure.
start with you. Yeah, Jay.
So I think one of the challenges with this is that pretty much everything is tied on the supply chain to one vendor, maybe two if you really look at it. And I think that actually causes a lot of the shortage issues because like people are forced to like essentially use like one piece of hardware. I think for us, we've been trying to be more flexible on what we can use and also use that to potentially deliver more customer value, making it easier for them to utilize a wider part of the supply chain.
And I guess, so we are largely like sidestepping the problem by betting on edge AI, where like once you pay for the hardware, essentially like the inference come for, so the marginal cost is free. The only challenge is that you can't fit like very large models on the edge, but fortunately for like, if you look at essentially fully general intelligence, you need like very large models. But if you look at like domain specific general intelligence, you could fit them into smaller models and they're performing pretty competitively as well, especially when you like really tune on the data as well. So in that sense, like, we are pretty much sidestepping the problem and betting on edge AI.
So actually, this was expressly the purpose of my previous company, Mosaic ML. We actually had a multi chip backend. We worked on TPUs, on AMD, and on NVIDIA, and you could even like have a training run, stop in the middle, and move to the other kind of hardware, even assuming that you had the same numerics and things like that. I think there are lots of companies now working on trying to make utilization of the existing resources better. And I think we'll get there. What's interesting though is I think inference is now getting to a point where we can bin pack it really well. And at Databricks, I was running AI at Databricks after my previous company was acquired, and we could bin pack like 95%. We had very few idle cycles anymore. On training, it tends to be large blocks. So, if I have a lot of continuous training runs to do, I can keep things pretty occupied. So I think we'll continue to get better. This is maybe we'll get another 50% better CapEx efficiency out of that. But fundamentally, I think we're at this point where even if you did that, we're not going to have enough because of energy. So I think that's actually the fundamental problem to solve right now.
No, yeah, have definitely also seen inference speeds increase, and I think for post training that's one of the big bottlenecks. So the faster that models run, the more people are able to use RL environments and post train their models faster. Yeah.
So Jay, maybe pick on that for a second. Do you think lack of availability or cost is keeping your customers or keeping you from scaling HUD as much as you want to?
Honestly, it was a bigger problem earlier this year. I actually do remember there was like a huge GPU shortage for one of our customers. So things were moving super slowly. But I think now things aren't really bottlenecked by that. I think it's more so data quality, all sorts of other stuff. I think so far it's been pretty clear waters.
And Zayn, you are working on helping heterogeneous hardware adapt or models adapt to heterogeneous hardware, maybe in that direction. Why has it taken this long for that type of technology to arrive? Shouldn't this have been part of the first order of business for all of the hyperscalers?
Yeah, I guess you would think so, but I think the pace of the industry has been so fast that getting something out, even if it's less efficient, is the primary goal, I'd say, for people. And I think you see this across the industry, and that's part of the reason why there's this huge shortage, is because things are not as optimized as they could be. Actually, one of my friends, Pete Warden, wrote a post yesterday.
I read it.
Yeah. Which kind of goes into this entire angle of ship something at any cost, get it out. And I think now people are starting to pay attention to, oh my God, this is very expensive, it's unsustainable, there's not enough energy, it's hard to find data centers. And I think things are moving in a direction where hopefully, the next few years will correct for some of that.
Well, I think there's another aspect to it. I agree with you. Speed is important, but I think what's also weird in this space is that typically in software engineering for the last, 40 years or something, you work through abstractions. And abstractions allow you to reduce complexity at whatever application layer that you want. In the AI space, and we started this with Nirvana, my first company, is that we actually broke the abstractions. We went sub-CUDA. We went to the machine code. We literally found hidden instructions in the hardware that we could utilize to make things faster. So we broke every abstraction and extracted performance. In ML, it's all about extracting performance. So you break the abstraction. When you break the abstraction, what the consequence is you can't port it at all. So if you want to make something run on Trainium or run something on NVIDIA or AMD, you literally have to have someone that extracts performance across the entire stack for each one. So that becomes very human. Compilers don't get you that far yet. And I think this has just been a fundamental challenge to this space, is that I can't be 50% off. Whereas with SaaS, who cares if I'm 50% off? I'm using 1% of the machine. If I'm 50% off, I'm using 1.5% of the machine. Who cares? But if I'm using 100% of the machine, it matters, right? It matters for your application. It matters for your OpEx. It matters for all these things.
Yeah, I think that's especially true. I always tell people about how all the abstractions are broken to the point that programming for these systems has regressed by decades.
Totally, you're writing machine code again.
and actually, that's another issue, is that it's relatively hard to find talent for the people who are able to work across the stack, because it's not actually something that's really been taught in school, because everyone's been like, okay, write in higher and higher level stuff, and then now people are trying to hack out assembly to get higher performance.
Yeah, I mean, Naveen, so you talked about two things. One is there's a disconnect between how efficient the hardware and the software stack could be. Do you think the future, give us your vision, because you've worked at the forefront of the hardware and the model training pipeline side. Is the future a full stack, fully optimized solution? Is it always composable? Is the ideal company mix and match, or is it kind of monolithic?
Well, I'll give one example. Like biological brains basically don't have abstraction. Intelligence runs on the physics, right? Just how it works. So I think if you want to build something that is hyper efficient, that's what you have to end up doing. Now, I think we're going to have some compromise, but I think it should be a rational compromise. I'm going to give up X amount of efficiency to get portability, to get scalability. And so I think the future is going to be something like that. The best product will be the one that hits that right. I don't think we've done that yet. It's been done out of convenience. Like, okay, well, everyone else built this model on CUDA, therefore I'm going to use NVIDIA GPUs. It's utter laziness, honestly, that we haven't done this more. Because I think you're absolutely right. The way we train computer science is through abstraction. Like, I taught some classes in grad school, and people don't even know what the machine code is anymore. I mean, electrical engineers might, but like most computer scientists don't. And I think that's something we need to kind of get back to. So yeah, I think we're going to get in this world where we say, I'm going to make this rational trade-off for this thing that I can tolerate some inefficiency for the sake of flexibility.
I think one more area to think about, and we're doing a lot of this, is, you know, as the layer, in some ways, moving the abstraction layer higher up might actually be better, where you try to abstract out like a platform or API layer,
Totally agree.
and then figure out how you can get like, you know, more AI models and stuff to actually fill in the gaps in the middle, rather than have people do every layer of that stack.
What do you mean AI models to fill in those gaps? You mean you're talking about like kernel gen and others, or do you?
Yeah,
I mean,
so
yeah.
one of the things that we do, for example, is like, you know, look at like automatic like kernel synthesis.
Yeah.
And really, you know, what you're trying to do over there is I have a bag of tricks, right? A lot of people like try to sell you some like fancy, I'm going to generate any kernel in the world. Like the way I think about this is that you have a bag of tricks, you have some like profiling information, and you're going to try applying those bag of tricks, look at the profiling and go back and forth. That's like what a human would do, right? Yeah. But now it's like fully automated, and you don't really have to think about doing this for every single piece of hardware. And even if you do have to do some manual work, it's like 20% manual work instead of 100% manual work.
Okay, I wanted to ask this question about the edge. Anybody can jump in, but Srikanth, you first. I think a lot of those of us that started working in AI or investing in AI or just getting exposed to it, the edge thesis was, it certainly must have affected Qualcomm a lot, but the edge thesis was like the thing that supersedes the cloud, or certainly should be larger than the cloud. Do you think that eventually happens, or do we need these AI super factories always to be part of the AI workload that we want to use?
I guess I see like a hybrid world. So there's certainly certain use cases where you need like continuous inference, like let's say always on and very, very like low latency. It's I don't see how, like, I think fundamentally it's tough for cloud economics to work. Like, you know, even if the model inference cost comes down, you still have to upload all the data to the cloud in real time, and the latencies won't work and so on. So I feel like whole plethora of use cases where there's no choice but to kind of essentially solve the edge AI. And I think, like, you know, we're making pretty good progress towards that as well. And I also see, like, in the future, like, you know, AI will be like electricity in the sense that, like, you know, it will be like ubiquitous. It's present in almost every device, and you just kind of take it for granted as well. So that's kind of how I see it.
Anybody else?
Yeah, I mean, I think we've had pretty sparse use cases here yet. I mean, you guys are doing stuff. There's some things coming out. I think there's going to be a paradigm shift. I think it's going to be robotics. That's going to drive a lot more edge, personally. I don't know when that'll happen. Is it 5 years? Is it 10 years? I don't know. But I think when robots get cheap enough, we need local control for those things. Yeah, you'll still have these AI engines in the cloud to do certain sorts of tasks, but I think anything that deals with real-time dynamics is going to be local. And actually, that's potential future that we're even building toward, is that building a computer that can deal with dynamics of the world.
That would be amazing. It certainly has been hard to raise money for companies that are working specifically in the edge unless you have tremendous business traction. All right, let's talk about future-facing stuff. We could address continuous learning and AGI, ASI. I guess what I'd ask first is, there's an efficiency basis we can all improve by building better infrastructure. Are there limits out there? We could talk about power, but are there any limits to the technology itself that keep us from getting there? And I know Naveen is working on a way around that. But maybe let's get an opinion from each of you on, when do we see a real wall, if ever, that isn't either power, or maybe investment dollars? Go for it.
I think to some degree, the wall already exists right now. I think what's happening is that people have been just building bigger and bigger infrastructure, getting better at cooling. But in terms of like the energy usage, in terms of the ability to actually build these systems out, I think we're kind of past the wall, right? We've gotten very good at like building big systems, but it doesn't necessarily mean that we can keep this going forever. So when does it actually completely break down? Maybe in the next couple of years it'll become like completely unsustainable. So I do think that we need to get like fundamental improvements in how we build these systems.
So wait, wall or no wall?
I'm in favor of there is a wall, but there is enough money going in that it's
You smash through it.
smashing through the wall at the
style.
moment.
Okay.
That's interesting. So I guess I was more thinking more in terms of like power efficient like neural networks. So like I was at Qualcomm working on like brain inspired like neural networks. I guess there's a scope for much more power efficient networks, but however, like the learning algorithm wasn't that clear. So in that, I mean, but I do see a future where we'll get like way more power efficient networks, I guess.
Through spiking, or no? You're not going to be specific.
That I'm not sure.
Okay.
I mean, I think the wall is energy. It's always going to be energy. I mean, I just look at 4 billion years of evolution on this planet, and computation has been energy has been the barrier for computation. I also think our version of what we call a computer, it's literally computation, numeric computation is only one version of what intelligence can run on. And so I think we'll come down to energy. I think you mentioned Landauer limit. That's a fundamental limit. The Landauer limit's a weird one because it is a fundamental limit, but it's also it presupposes a certain kind of functionality of the system in some ways. There's a whole adiabatic people, adiabatic computing folks, which I think are a little bit nutty, but that's a whole other thing.
I never count out that stuff until like.
Look, I don't disagree. Maybe it's nutty now, but like it becomes science later. But I think we haven't even gotten to the point yet where we're in close to needing to go adiabatic yet, because we're so far away from fundamental Landauer limits. I mean, we're probably 9 orders of magnitude away, right? So let's figure that out first. Let's get close to biology. Then we'll start to approach those limits. But the limit is going to be energy. That is fundamental, and I don't think there's any way to get away from it at some point.
Yeah, definitely agree we're speed limited by energy in some capacity, but I actually don't think there's any wall. I think you can sort of, at least from a model performance standpoint, like if you can get the right data and you can model the task sufficiently enough, you can really get these models to do anything. So yeah, there's definitely like some like speed limit by energy, maybe like availability of hardware, but really I haven't really seen any like real things that models haven't been able to do given enough effort. Okay.
Last question from me before we open to audience. I think we have 10 minutes left, so be thinking of something to ask. What's your favorite business-related application for AI? I guess what I mean is, what's your favorite application for AI? What's your favorite business that you see out there that's operating?
I guess I'm probably very biased when I say it's all the coding agents, things
IDs.
like Cursor, yeah,
Sure.
Cloud Code, et cetera. But this is probably a very, very biased viewpoint because I think they fundamentally change like the productivity of people like working on building the new set of systems.
And do you think any of the barriers we talked about prevent maximizing the use of AI for that?
I think the main issue that you run into with all these coding agents is always like context and being able to absorb like the entire code base. And I think getting around like the fundamental wall limits actually involves like being able to do some like hierarchical division, like being able to understand different things, just like how people would probably go through a lot of this task. And today it's very much a feed all the information with some smart prompts. And I think that ultimately leads to what we have seen, or at least my experience has been that even for models that have huge context, the more context you give it, the more confusing the results get at the end. And sometimes you're like, please don't do this, and it starts doing exactly that because it's somewhere in the context. So I do think like being able to build better models will allow us to surpass some of these limits. And the better models might not actually be bigger; they may actually be smaller models that are more catered towards like specific tasks you want to accomplish.
What would change? Is memory a part of that story? Do you think, agentic memory or even physical memory?
Yeah, I definitely think both of those are part of the story. So the first one is just being able to understand what parts of the context are actually important, right? And I think there's there's a lot of work going on that and trying to like identify and prune context based on like a specific task or set of prompts you want to process. Then I think the other thing to remember is basically energy is the bottleneck, and energy comes from either computing or moving the data around, right? And fundamentally, you have to do something to keep the data closer to where the compute's going to happen. So there's a lot of new work, like assuming for at least on the digital side, where you're trying to do like more memory stacks and things like that to actually make it much more efficient.
Favorite application?
I mean, I have to agree with Jane in the sense that so all the coding agents are awesome. I'm also interested in essentially applications that's helping like sales and marketing. But I would say one of the things that I was thinking more about was essentially this communication versus collaboration kind of a trade-off. So the AI tools are essentially making the individual people a lot more efficient. So essentially your computation units are becoming much more efficient. And then your collaboration is kind of becoming the bottleneck, right? So I'm also watching out the space for AI, which is really helping out like, an organization or like a set of humans kind of collaborate like, much more better. Some of the startups are coming in that space as well.
Awesome.
I'll broaden your question a little because you said operating business. So these aren't necessarily operating businesses, but it's a use case. I mean, like I think back to when I was a grad student, like finishing my thesis, and like at that time doing research for like answering a specific question was super hard. I mean, it was all manual. You basically had to read the paper and you had to like say, okay, is this right? No. Okay, if it is, then find something that's referred to in that paper, go look at that, and finally get your citation. That whole process is super fast now. Like I can just use like a deep research type agent to do this kind of stuff. I mean, Google has it with their Scholar agent. I can use ChatGPT for the stuff. Like I think that is such a game changer. No one even talks about.
Are you using it conversationally, or are you kind
I am.
Yeah.
Okay, I basically like I use it to like research something. I'll be like, all right, so tell me all the literature on nonlinear dynamics used for neural network compute. And it says it goes and searches everything. It's like these are things that probably match. Okay, now what does this one say? How does that differ from this one? You can just keep on going and going and riffing. So it's becoming this design tool for thought.
Cool.
Like I'm literally like thinking with it. I don't think it's giving me anything new that no human has ever done, but it's allowing me personally to access that in a way that's useful for what I care about. And I think what we're going to see is going forward is, and I think Jeff Bezos's new company Prometheus is about this: is how do I build an assistant for designing anything? That's going to be huge. I think that's where I think it's just killer. And I would say coding agents are a subset of that to some degree.
Yeah, my favorite new genre of AI businesses is like these RL as a service startups. So like they'll find some domain where models aren't particularly great at, and they'll make a whole like data stack of like RL environments and like SFT data in order to train like a really specific model that's say like Verilog or some capability that's like relatively niche, and then charge based on that model usage. I think that's a really cool category that I think is going to explode next year.
All right. Audience, go for it.
So you heard Qualcomm, and you talk about power efficiency. Do you have any edge-based model? What is your on the shift of inferencing from cloud?
You're the edge guy.
So I was at Qualcomm as well, working with Naveen and Jeff and so on. I mean, we see like basically like we are betting on edge, and like essentially, so if you take the performance of a very large model, that's kind of matched by like a small model that can be fit in edge, and even like the amount of compute that you can fit in edge is also increasing quite a bit. I see a lot more and more use cases being covered at edge, so that's definitely something that we are betting on.
Just because I noticed none of your favorite applications are looking at edge-based, so that's why I was wondering. It sounds like you still see that you need cloud-based. However, so like one thing I was curious, you have agents that do everything. Like I love a laptop, airplane, good coding.
I think we need better robots. That's a form of a robot to me, right? And I mean, you're in that specific instance is because you didn't have connectivity, but you didn't care so much about latency. But in certain applications where you do, like I'm thinking about an agent as a physical thing, right? Hey, go pick up my laundry or whatever. Like then you're going to need, it's going to drive a lot of edge compute, I think. I don't know when that future happens though.
So I think one thing I wanted to add is we also started off as an edge company, and one of the challenges with the edge is how do you define what the edge is, right? I think it means many different things to different people. I do think there's like a lot of opportunity to like build collaborative models for like your laptop to work with the cloud, especially on the coding side, because you can have a bunch of models scan all your local code repositories and stuff. That can guarantee a lot more like privacy. I think one of the challenges on the edge space is that I think the cloud space basically sucks all the oxygen out of the room. And it does make it very, very difficult for anybody working on the edge to actually build a business around it. One, because the use cases are very, very desperate. And two, because like it's, as you pointed out, it's relatively hard to work on funding on the edge space because it's hard to scale those businesses.
That can change very quickly with the right successful entrepreneur.
Yeah.
Samir.
I was going to say, like, at least on the high level part, I think the pipelines for data are just going to get much more efficient. I think right now it's still commonplace to have like a model that's like has a year out of date training data. I think like, yeah, next year that's not really going to be a thing. I think things are going to update much quicker than they currently do.
So I think the thing that I was going to add to that is I think right now pretty much everything has turned into a very much like imperative style program, right? And what we really need over time is to figure out like what is like the SQL, like the high level language for like building out these agents. And then once we can get to something like that, it makes it much easier for you to then take that representation and actually map it to something lower level. Because right now you're basically trying to translate like one low level spec to a different low level spec, and that's going to be very difficult, right? And I think to some degree, like people talk about things like the CUDA moat. The CUDA moat isn't really about the CUDA language, right? It's all about like actually the moat around effectively writing code for NVIDIA's architectures, very specifically. So I think if you're continuously trying to map code written for one architecture or another, you're going to be one step behind. So the question really is like, what is the dialect that you can define that you can then easily translate into all these different hardware over time?
I mean, Triton tried to do that, or was trying to do that a bit.
And it's very hard still.
Yeah, it's still not great, right?
Yeah.
Okay. Oh, sorry, David. Yeah. You knocked him flat, Dave. So yeah, I mean, like you're asking about the boundaries between that handoff, right? The edge, yeah.
Yeah, I guess the question over there is future code going to be AI wrapping some regular software, or is it going to be the other way, whereas regular software has a thin layer around a bunch of AI, right? And I actually think we're probably moving much closer to the paradigm where it's a little bit of regular software wrapping a ton of AI. And then the question is like, how do you define like what all the guardrails are and the interaction models? And ultimately, I think you need to have some set of rules where you can actually specify, here are the guardrails, here's how it actually interacts with all these additional systems, and then essentially just build interfaces around those things.
I mean, we tried to do some of this at Databricks when I was there, was yeah, give you some declarative stuff that's like, these are directives, must be true, and then like effectively do an RL loop, right? Like where you say, okay, well, give me an agent that does X, Y, Z. Here are the constraints. Then have it do X, Y, Z in some examples and say, this is no good. Do this way. And so give it feedback and then refine. So I think it's really interesting. Kind of reminds me of being back at Qualcomm, because we were thinking about these problems like what, 2012, right? And actually one of the things I still remember from one of the keynotes that Matt Krob gave was, we need machines to be taught like we teach a dog. It's an RL problem, right? We want to train them to do the things we need them to do, but then have a bunch of assumptions baked in to do the right thing, you know? So I think there's going to be some kind of interface there that looks a little bit more like biology.
Okay, I think we are over time. So thank you, everybody. Thank you for coming, and thank you for listening to our session on token efficiency.
Thanks.